Alright, so what we have learned yesterday is we start from this exercise, 17F. Okay, and we learn three definitions: limit, define, and continuity. Have a think about what is limit. Like, it's very important definition here. Limit is not actually on that point, it's approaching to a value, and the y value get close to a particular level. Okay, so the way I use is like, think about there's a wall and the people from each side go along the path and which level they actually arrived. If left hand side and right hand side arrive the same level, then we can say the limit does exist. Left hand side limit and right hand side limit is the same. So continuous, like there's three steps we need to prove for continuity. So you need to say step 1, it is defined at point. Number 2, it is limit exists at that point. Number 3, the limit and the defined value are the same value. Okay, I give you a really extreme situation here, which limit does exist, it is defined at that point, but the limit and defined value are different. So this is not continuous, which is very easy to think about the shape of the graph. If I want to say that point is continuous, that point must be connected. Okay, that point must be connected. So there's no jump, no holes on that point, then that point is continuous. Okay, so that's what we learned yesterday, and then we do 2 examples whether they are continuous or not. So today we'll use the definition for limit to think about. Okay, go up to the front. Okay, to think about derivatives. Okay, so what is derivative? Okay, what is derivative? So I skip like in one day, like I go 17b first. Like I tell you what is the rule for polynomials if you want to derive the polynomials. As I drag the n down and reduce the power by 1, that's the derivative. Okay, for polynomials. But okay, let's just think about why it is true. Okay, why it is true. Where that rule coming from? It's just not someone make it up. Like it must be somewhere. Like I can find it. So how I can prove that is true? So recall from the exercise 16D, instantaneous rate of change. Have a think about last week we learned instantaneous rate of change. There are 3 ways we're going to do it. If we say case, okay, I use that point and I choose another point which is really close to that point. Like say I want to find the derivative at 2, then I choose a point at 2.00001. Okay, I substitute into the function. Find the difference between the y value and divide by 0.0001, and that's how we find the derivatives. Okay, approximately. Number 2 is at that point we draw a roughly correct tangent line, and then we use that point on the graph and tangent line and another point on the tangent line, which is easy to read, and find the gradient of that tangent line. And number 3 is what we're going to learn today. Okay, number 3 is what we're going to learn today. So first thing you need to understand, derivative, if we use symbol to represent, that's dy dx, or f dash x, or anything g dash x, dy dt, according to what is given to you. What is that value tells you? Okay, why we want to know the derivative, what that tells you. That's the gradient of the tangent at particular point. Okay, make sure you understand why we want to know the derivative. Okay, the derivative is the gradient of the tangent line at particular point. Okay, what that further tells you, the gradient of the tangent line is the rate of change at that point. Okay, it's not it's not a straight line, then we don't have a continuous rate of, like a constant rate of change. Every single point, the rate of change is changing. So why is changing? Because every single point will got a different tangent line, and then all these tangent gradients are different. So that's why it's called an instantaneous rate of change. That rate only works for that single point. Okay, it only works for that single point. So dy dx is the gradient of the tangent, and the gradient of the tangent tells you the rate of change at that particular point. Okay, so you need to understand what you're looking for now. So we're looking for change, for rate of change. How the y value change according to each unit of x change. Okay, so that's the meaning for rate of change. Okay, now have a think about that. I have a function fx. Okay, I have a function fx. I want to know the gradient at f dash a. Okay, I want to know the gradient at point A. So according to chapter 16, what we do is fa plus h minus fa and divide by h. Okay, fa is the y value of that point. Ya plus h is the y2 value. Okay, at another point really close to that point. What is h? H is an extremely small number at 0.0001. That's the way we did it before, right? If say a is 2, then 2 plus h is 2.0001. We put those two values into fx and subtract between the y values. And then divide by h. Okay, divide by h. H is the subtraction between the two x, is the change in x. Okay, now have to think about that. Are you talking about like a really small h, right? 0.001 is better than 0.1. Okay, 0.00001 is better than 0.001. Okay, so the smaller the better. So in an ideal world, what do you want? What do you want h to be? Like if it's extremely small, what that value approaching to? If I say something really, really small, keep decreasing, what will reduce to? 0. Okay, 0.00000, like infinite many zeros and 1, like that's approximately 0. The smaller the better. In other words, I want it approaching to 0. It can't be exactly 0. If it's 0, it's exactly the same point, and there's no change in y values. So I want h to approach 0. Okay, approach 0. The smaller the better, right? The smaller the better. You know, the smaller the h, the more accurate you will get for that approximation value. When h is like almost 0, like it's approaching to 0, then that value is approaching to the true value you're looking for. Okay, it's approaching to the true value you're looking for. Okay, so then we have this formula here. Okay. Before f dash a just equals to that, then you choose a really small h. Okay, do not cross that out, okay, just for me. So before f dash a, we say is that, and h is a really small value. Now I add another, like before it needs to be approximation sign, like approximately equals to that. Now I have a straight line here. And I add one component, is lim h approaching to 0. I want limit, okay? I want to know when h really go from both sides, decreasing near 0, what's the value approaching to? Even though h can't take 0, it's okay. I want to get close enough to 0 and see what the value looks like. Okay, so limit is not actually h equals to 0, it's the behavior as h going towards 0, what the value looks like. Okay, what this value looks like. So that gives you exact value of f dash a. Okay, give you exact value of f dash a. So f dash a means the instantaneous gradient at x equals to a. This at x equals to a, this value, okay, what you find here is a value, okay, a number. Okay, a number. That is only gives you the gradient at x equals to a at that particular point. If we extend this a little bit more, we have something called first principle. This is something really important. What is first principle? That's this line here. That is called first principle. Why that is first principle? This gives you an expression for the derivative. So it's in terms of x. It actually tells you all the values. You can find any gradient. When you substitute x equals to 1, x equals to 3, you can substitute different values to get different gradient. Okay, so not only a particular point. So what has been changed is like change the a to x. Okay, change a to x. Instead of talking about a single point, let's talk about a more broad idea, like x can take any value. Okay, x is any point, like you substitute that in. So first principle, let's just have a revision on how do we evaluate limit. Okay, that's 3. Let's write the 3 a little bit far away. The 3 is the function here. Lim h approaching to 0, 3. What do you have here? The limit for a constant is
0.
It's not 0.
3.
It's 3. Okay, it's the constant itself. Okay, let's have a look at this one. Lim h approaching to 0 to 3x. What do you think that will be? I heard 0. I heard 3x. Okay, if you want to say 0, how do you get 0? Why is 0? Sub in where? Why is h approaching to 0? Why sub into x? There's nowhere you substitute that. You can see that? There's nowhere you can substitute that. So you can treat 3x just like a constant. Okay, 3x is a constant because there's no h. This function itself is not related to h at all. Okay, it's nothing to do with h. It doesn't matter. It doesn't matter what h approaching to. This function will still be that function. Okay, treat x not as a variable. It's just like a number. 3x is a number because h. This function we don't have h. Okay, so the limit when we talk about something not exist, it doesn't affect what we have before. So it's just 3x. Okay, what do you think this one will be? Yep. You sub h equals to 0 in this time. And h get cancelled. So it's 2x squared minus 3x. That's the limit for this. It's a little bit different than what we learned yesterday because it's at the component of like x. But it's okay. Treat x as a constant because you are only substituting h equals to 0. Okay, after the substitution, that's it. Okay, number 4. Can you substitute directly here? No, you can't substitute directly. So what you need to do for step 1 is simplify. 3x squared plus 4. And then there's nowhere I can substitute h anymore. So that is directly equals to that. Okay, I canceled h from that. Divide h on both top and bottom. Or you can take the common factor of h for the first line, and then the h get cancelled. So if sub h equals to 0, there's nowhere to sub h equals to 0, so the function maintains the same. Alright. Good, good. Let's have a look at example 2. Okay, example 2. For the curve with equation x squared minus 2x. Okay, I'm drawing this function for you already on that side. Find the gradient of the chord PQ, where P is the point at x equals to 3. Okay, let's label the point P at x equals to 3, which is here. And the point Q is at the point 3 plus h. I don't know where is 3 plus h. I can just randomly choose a point. Okay, randomly choose a point. That's 3 plus h. A y value. And I want to find the gradient between them. Okay, I want to find this gradient. So again, it's y2 minus y1 over x2 minus x1. Even though that's a really small right angle triangle, okay, so it's still y2 minus y1 over x2 minus x1. So for the point P, we have 3, 3 squared minus 6, 9 minus 6 is 3. So the point P is at the coordinates 3 and 3. The coordinates Q is very interesting. That's 3 plus h. What do you think the y value will be? if the x value is 3 plus h, what do you think the y value will be? In terms of h. If x is 3 plus h, in terms of h, what is the y value? If, yeah, you substitute, okay, you substitute in, because you know the x value, you definitely know the y value. So sub in 3 plus h squared minus 2 times 3 plus h. That's 9 plus 6h plus h squared minus 6 minus 2h. So what I have is 4h plus h squared plus 3. Okay, if I simplify that, 6h, 2h, that's a 4h plus h squared, and then plus the 3 is 9 and 6. Okay, I still use y2 minus y1 like the gradient equals to, okay, 4h plus h squared plus 3 minus, that's y2, minus y1, that's the 3 over x2 is 3 plus h minus x1, which is 3. So the bottom is h. The top is 4h plus h squared. This bottom is h. What I have here is 4 plus h. Okay, 4 plus h. Well, how do I get the gradient? The gradient is f3 plus h minus f3 over h, right? That's the gradient. y2 minus y1 over x2 minus x1. That's h. That's the gradient. So 4 plus h is the gradient, which tells us the gradient of p and q, it depends on the value of h. Okay, the larger the h, the higher the gradient. The smaller the h, the smaller the gradient. Okay, it depends on the h. So if h is 1, then the gradient is 4. If h is 2, then gradient is 6. So have a think. Find the gradient of the curve at PQ when h equals to 1. So at point 1, h is 0.1. Then the gradient equals to 4.1. Okay, 4 plus 0.1, that's just 4.1. Okay, that's just 4.1. Okay, hence, find the gradient of the curve at P. Find the gradient of the curve at P. Find the gradient of curve at P. So what is looking for? Give me a math representation. What is asking for? Like F something? The gradient. What is the gradient? What's the symbol for gradient? You see what? You know that's the gradient. You see what is talking about gradient? I said at the very beginning of the lesson. I said near 17a. What is derivative? How do you know that's talking about derivative? If I give you fx, is that talking about derivative? Sorry, what? That. Yeah, finding gradient. What symbol? Like if that's a fx, dy dx, or like this question is giving you f. So what is f dash x? Okay, you're looking for f dash x. And then at point P, so you're looking for f dash 3. You need to know what you're looking for. Okay, you're looking for f dash 3 because it's the derivative, and the symbol for derivative is dy dx or f dash something. Okay, f dash 3. F dash 3. So have a think about the formula we have. We haven't learned 17b yet. Okay, we haven't learned 17b yet. So assume you don't know how to do the derivative, but think about the thing above the first principle. Okay, this formula here, a value. Okay, similar to first principle, but it's not actually first principle. It tells you lim h approaching to 0, fa plus h minus fa over h. Okay, that's the formula you need to use. So what does f dash 3 equals to? Is lim h approaching to 0, f3 plus h minus f3 over h. Okay, over h. Okay, is that looks familiar to you, this expression? Do you find it before? What is that? Yeah, so what's that? Can I simplify it? Go back to the previous page. What I have for question A is exactly what I find here. Okay, we assume h can take any value, okay? And that's the expression for f3 plus h minus f3 divided by h. It's just reduced to 4 plus h after all this calculation. So what I will have is lim h approaching to 0, I change that to 4 plus h because I did calculate it before. Okay, I did calculate it before. And what do you think that equals to? What that equals to? 4. Okay, 4. So at that point, it's just a 4. Okay, at that point, it's just a 4. So the derivative at point 3 is a 4. Okay, let's see. C is looking a value, okay, a number. What I want to get is a number, okay, the number of solution, like the value of the solution is 4, okay, I get 4. 4 is my final answer. Compare C and D. Compare C and D. D says using the first principle, find the gradient of fx. Okay, what you're looking for is f dash x. The gradient of fx is f dash x. What you're looking for is f dash x. At any point of x. I don't want a specific point. I want a general expression for any point to be substituted. Okay, I want a formula that contains like all the possible situations, not only at 3. So first principle. So when you see the word first principle without thinking, okay, what you write is that. You must remember that. Okay, you know what's first principle? The first line, what you write is just exactly here, okay? And it doesn't matter what function you have. The first line is always lim h approaching to 0, fx plus h minus fx divided by h. Okay, that's 1 mark. Okay, that's what's 1 mark for you. So that's first principle. If you want first principle, that is first principle. And then according to what f you have, you substitute that in. So for example, in this case, fx is x squared minus 2x. So x squared, so become x plus h squared minus 2x plus h minus, okay, that's fx plus h minus fx. Fx is x squared minus 2x over h. Okay. So what you have is lim plus lim h approaching to 0. And what you need to do next is expanding or simplify or trying to do something to that. Okay, you can't substitute 0 in now. So you need to simplify. So what we can do is just expansion. X squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x divided by h. Okay, I'll tell you something. Any term without h, okay, any term without h needs to be cancelled each other. Well, if it's not cancelling each other, it means you're doing something wrong. Okay, it means you're doing something wrong. the term, like for after this step, the term cx squared without h, the x squared must be cancelled with that. Think about your x squared cannot divide by h. The h will still be the denominator, so it's not going to stay there. Otherwise, you still can't substitute h equals to 0. And we have, okay, 2x and 2x. Okay, 2x and 2x. So what has been left is 3 terms. Okay, 1, 2, 3 here. So if lim h approaching to 0, okay, 2xh divided by h is 2x. H squared divided by h is h. Minus 2h divided by h is minus 2. Okay, it can be simplified to that. Okay, it can be simplified to that. Okay, then you can sub h equals to 0 now. There's no denominator. So what I have is 2x minus 2. So f dash x equals to 2x minus 2. Okay, so that is like you can sub 3 in now. Try sub 3 in. F dash 3 is 2 times 3 minus 2, right? Which is 4. It's exactly the same as what gives to you at the beginning. Okay? Hence, find the gradient of the tangent at x equals to 3 and x equals to a. So f dash 3 is 2 times 3 minus 2, that is 4. F dash a is 2a minus 2. Okay, just do simple substitution then. It's just simple substitution. Okay, F. Find the coordinates of the point on the curve at which the gradient of the tangent equals to 0. So the gradient of the tangent is, okay, when you see the gradient of the tangent, what should appears in your mind is f dash x, okay? It tells you that f dash x is 0. Okay, f dash x is 0. So 2x minus 2 needs to be 0, x will be 1. Okay, so when x equals to 1, then the gradient will be 0. The gradient will be 0. So, I want the coordinates. Okay, I want the coordinates. So what is the coordinates? I need to sub 1 back into the function. f1 equals to, okay, 3 x squared, 1 squared minus 2 times 1. That equals to negative 1. So 1, negative 1 will have a gradient of 0. Go back to the graph above. Where do you think 1, negative 1? Where is 1, negative 1? Where is it? The turning point. Okay, 1, negative 1 is the turning point. Have to think about why the gradient of the tangent is 0. Okay, the tangent will be a straight line. Okay, it's just a horizontal straight line. Then the gradient must be 0 for that straight line. Okay, that's the turning point. Think about you want to sketch a tangent. You're not going to sketch like any way like that. It must be a straight line. Think about tangent. Tangent is only touching 1 point. For turning point, how can you just draw a line, touch it? It's only the horizontal one. Okay, so that one will be a 0 gradient, which makes sense. Okay, which makes sense. All right, I'll give you 5 minutes to think about example 3 using first principle. Okay, so this is the example. How do we use first principle for exercise D? So I give you 5 minutes to do example 3 by using first principle. Okay, you remember your answer should be minus 3x squared. Okay, you know the rule in part B, right? How do we do the derivative? Constant is just a 0. Bring the power down, that's a negative 3. Reduce the power by 1, that's a 2. So it's negative 3x squared should be your final answer. But you can't use that directly. You need to use first principle. Okay, what is first principle? Again, first principle is lim h approaching to 0, fx plus h minus fx divided by h. Substitute in and try to figure it out. Expand, and then simplify it. And substitute h equals to 0. Just let you know. You need that. A plus b cubed is a cubed plus a squared b plus 3ab squared plus b cubed. You need this fact, okay? So for a minus b cubed, that's a cubed minus 3a squared b plus 3ab squared, not cube, squared here, minus b cubed. Okay, if we talk about that, like another thing you may want to know is the difference of the cubics. A cubed minus b cubed, that's a minus b, a squared plus ab plus b squared. And a cubed plus b cubed, that's a plus b, a squared minus ab plus b squared. Okay, that's for formulas. Except the perfect square, you must know this as well. Okay, you must know these 4 as well. Write smaller. Make sure you have enough space to do first principle. Okay, give you 5 minutes. Just finish this one for me, please. So when you see first principle, that's like what you're looking for is the derivative f dash x. That equals to the lim h approaches 0, fx plus h minus fx divided by h. Okay, the thing is, you know what is fx. Fx is 3 minus x cubed. You know that. But what you don't know is fx plus h. So, if you don't know what to do with that, let's start from the simple idea. Fx equals to 3 minus x cubed. What f2 equals? You know what is f2? f2 is 3 minus 2 cubed. Instead of x, you put 2 in. Okay, my next question is, what is fb? fb will be 3 minus b cubed. You put b instead of x. Then the last thing I'm asking is, what is fx plus h? X plus h is 3 minus x plus h cubed. Instead of x, you put the new thing in the bracket. Okay, that is what you should have. So this time, what I will have is lim h approaches 0, 3 minus x plus h cubed minus, okay, put in that in the bracket because you subtract the difference between those two values. That's what you're going to have. Divide by h. Okay, divide by h. So that's lim h approaches 0. Okay, another thing. Lim h approaches to 0. You need to have that keep going down. Okay, you can't just miss it in the middle. Until you want to substitute h equals to 0. That disappeared in the last step. Okay, you should keep having it. It's not going to carry down. Okay, you need to write it literally every single step. And then I want to expand. 3 minus x cubed plus 3x squared h plus 3xh squared plus h cubed. But a lot of you forget the bracket here. That's why you have a wrong value in the end. N minus 3 plus x cubed divided by h. That's lim h approaches 0, 3 minus x cubed minus 3x squared h minus 3xh squared plus h cubed minus h cubed minus 3 plus x cubed divided by h. So what I'm going to cancel is those two and those two. What I have left is the middle 3, always a negative sign. Then I will have lim h approaches to 0 minus 3x squared minus 3xh minus h squared. Okay, divide h for every single term. Okay, divide h for every single term. And then the last step is substitute h equals to 0. What I will have is minus 3x squared. Okay, f dash x equals to minus 3x squared. That's one line. Okay, the last line is minus 3x squared. Very important, like it's testing your basic calculation skills. Okay, basic calculation skills. If you can't do it, which means some calculations, you can't do the calculations. Alright. So I'll stop here. That's the full exercise of exercise A, and you know what is exercise B. I'll check also with you next lesson for exercise B, and we'll do C and D quickly next lesson. Okay. So okay, let's finish here.